with Benji. Okay, and together with Benji, I co-organized this meetup. So this meetup is a space to share knowledge on data visualization with the Zurich community and more broadly with the global database community, especially since the pandemic. And today we welcome Dr. Matthias Stahl, who is co-leading the graphics desk at Der Spiegel, which is a German news magazine. Matthias is a trained biochemist and bioinformatician, actually. And he discovered creative interactive data visualization in the process. And in 2020, he founded his data visualization studio called higsch, if I'm pronouncing that correctly, and where he specialized in creating interactive data visualizations on a number of topics like politics, medicine, human rights. I highly recommend they go check it out. And if I understood correctly, recently he joined Der Spiegel. And today he's going to show us how to create unique data visualization with Svelte and D3. He's going to, we were promised a live coding session as well. And he's going to tell us how to make Svelte and D3 work together, what makes Svelte a good choice for data visualization, and show us some interesting examples. So Matthias, I'm handing over to you.
Yes, thank you very much, Christina, for the nice introduction. And I'm really happy to be here in the Zurich Database Meetup, which is, I guess, quite global in these times, as everyone can access it via Zoom, which is maybe a positive side of this pandemic. And yeah, let's start right away. I'll share my screen, and I thought I share my complete desktop, as I will switch a little bit between slides and browser and yeah, my live coding window. Or so let's see how that goes. Yeah, I think this will be really fun now, and I will show you a little bit what we do at the newspaper, at Der Spiegel, which types of visualizations we do, and then I will quickly focus on the more complex visualizations that we build with Svelte, the front-end framework, and D3, the graphics library for the browser, mostly interactive stuff. And then, yeah, we'll have a look how to combine these two tools together to build a rather simple visualization, just to show you how it works in principle. And afterwards, I'm of course open to any questions that you might have. Yeah, to start with, I'm located here in Hamburg in northern Germany. And here on the picture, you can see the main building of Der Spiegel, which is a weekly newspaper here in Germany. And we basically have this print magazine here. This is the current issue, which has always around 120 pages. But we also do have a website. So the print magazine, as you might know, was very popular in the last decades, but now, as everywhere in the media business, print issues are going down. We still have 700,000 issues per week, which is still quite a lot. But of course, our main business is now online on our spiegel.de website, where we have now around 23 million unique visitors per month. And with that, we are one of the 4 top news websites in Germany. And I am, together with my colleague, co-leading the graphics desk here at the newspaper. We have 20 colleagues, and these colleagues divide into people who are really doing pure graphics, but we also have people doing design, more strategic design stuff. We also have a couple of developers, and we have journalists that are capable of editing stories. So we also produce our own stories, visual-driven stories, of course. And yeah, so data visualization in the newsroom is maybe the platform where the most public data visualization is taking place, but it also comes with some specialties. There is a wide variety of different graphics types, of course, that we can build. So this is a rather simple bar chart that we have very often, for example, in our print magazine. So we do these, of course, in our department. And actually, it's really like 80% of the amount of graphics that we do each week is graphics like this one, simple line charts, simple bar charts. Yeah. Then we have some like more complex charts, which are then unique for a story that is in the print magazine or unique for a visual story that we have on our website. So this, for example, is a map with some special features. And we also do some interactive graphics. This, which is built where we're currently showing the gas reserves in Germany and how they develop each day in comparison to recent years. And this is like fully interactive, so you can hover over it, get the values for some special dates, or you can switch the views. So this is like the range of different graphics that we do. Sometimes there is even more special creative graphics, I would say. So I show you some of them in the end as well. But all of these graphics basically have in common that we need to create them with a very high speed, usually, because that's maybe a specialty in the news business. There is some news, and then you need to quickly react to produce some visualizations, quickly bring them into the print magazine, and quickly bring them onto the website. So we need to be very fast. And at the same time, of course, we need to be very accurate, because we have millions of readers and they all check what we are doing. And we have, like, I don't know, for example, politicians that use our information for their decision making and so on and so on. So we need to be very accurate. And third point, there needs to be a lot of originality. So people need to see that this is a graphic which comes from Der Spiegel. This is an interactive visual story piece, for example, which comes from our house. So this needs to be, we think that this needs to be identified quickly by the people, so that speed, accuracy, and originality are the 3 points that I think are very special to the newsroom data visualization business. And of course, when you take these different types of graphics into account, and then you can also see these 3 key properties that we need to fulfill here, then it's of course interesting to have a look which tools we use to build the graphics. How can you be accurate and fast at the same time? And we basically use 3 different tools, but before we use any of these tools to actually produce the graphics, we always go for sketching. Because at the beginning of almost every graphic that we do, we want to order our ideas, we want to brainstorm, also brainstorm in little teams, for example, and we need to communicate with, the writing journalists, for example, if that graphic fits to the text and so on. And to order these ideas and to bring the ideas to paper, we use sketching, and we do that with really pen and paper, because we think that we are then independent of any tools, independent of any limitations that tools might come with. And yeah, sketching is a really great and simple tool that you can also use to start visualization, to evaluate all the ideas. And then we basically have 3 different tools that we rely on. And just by showing you these 3 different complexities of graphics again, for the less complex graphics, we usually use Data Wrapper. And I guess you might all know this company in Berlin based here in Germany as well, which is a no-code tool to simply produce graphics with certain style guides that you give them. And the interesting thing here for us is that with Data Wrapper, we can produce our online graphics and the print graphics just as one graphic. And then we can just decide, okay, do we send this to the print channel or do we send this to the online channel? And then it just works. For the more complex stuff that is not possible in Data Wrapper, we use standard tools like Adobe Illustrator, also in combination with AI to HTML. So this is a tool which was originally developed by the New York Times. And with that, you can convert the static PDFs or PNGs or whatever you have from your graphics to an HTML file, where you have a background image, but all the text on top is real HTML. And so that's quite nice for the website, because then we can produce like, I don't know, 3 or 4 different graphics for 3 or 4 different device sizes. And then AI to HTML will automatically play the right graphic size for the right device on like in the app or on a desktop website and so on. Very handy too. And for all the interactive stuff that is a bit more customized and a bit more complex, we indeed used Svelte in combination with D3. So here, yeah, for example, this gas reserves tracker that we have on our website right now is completely built with Svelte and with a little bit of D3. And Svelte and D3 together is really a combination that I love a lot, and my team loves a lot, and a lot of people out there love a lot, and maybe you have heard of those two. So Svelte is basically a front-end framework, which is from the concept similar to React and Vue, but it works completely different under the hood. It's more a compiler, so you can easily write code, which is easy to understand. You'll see it in a second. And then it gets compiled to a compact piece of JavaScript that you can then put on your website. And it handles all the interactivity. It handles the buildup of your application, of your visualization. And on the other side, D3, which I guess almost all of you also will know, is the graphics library for the web. It's basically just a collection of different functions that you can use. And I would say in former times, you could build a website completely with D3. You could build a complete interactive complex visualization with D3. But few people did it because it's not that easy to understand how it works. And also the coding style of D3, I'll come to that also in a second, is not that easy to understand for other coders or readers of your code. And what we and many others found is that when you combine these tools, so when you have Svelte to build up your visualization and to bring it on the website, and then use some selected functions from the D3 graphics library, then you really have a very powerful combination to quickly produce visualizations, to accurately produce these visualizations. And Svelte also comes with some nice features that you can have like standard components, so that you can build in a CI, a corporate identity, also to your components, which makes it easy to produce also graphics with a certain originality. So with the combination Svelte D3, these 3 key properties that we need in the newsroom, you can have them very cheaply. But let's have a deeper look, a little bit of theory now before we start in the code editor a little bit. So when would you use Svelte and when would you use D3? So Svelte is always good when you want to manipulate something on your website. And when I mean website, I mean visualization, I mean applications, all the same in our case. So when you want to move parts around, when you want to have some interactivity like a tooltip which is popping up, then this is handled by Svelte because Svelte is perfectly built for that. It's also possible by D3, but it's a little bit cumbersome to use D3 for these kinds of things. Then also when you have transitions, when you want to move dots around in a scatter plot, for example, then Svelte is perfect to implement these transitions. Or in general, the user interface of your whole application, this is easily built by Svelte. And then on the other hand, there is D3, and I would say D3 is good for the math and the paths. So that means when you have when you want to calculate pixel positions of the dots in your scatter plot, for example, or when you want to draw a line, which is a path in the D3 SVG world, then D3 has very handy functions to just calculate these paths and the math behind. And also transformations, for example, you have a date in milliseconds since 1970 or something, and you want to transform it to the date with the format of I don't know, Europe or the US or whatever, then D3 has already a collection of functions that you can just use, and that easily gets you the right results. So Svelte is the basis for your visualization, and D3 is just a function library that you can use. And I always use, I don't know, a handful of D3 functions for standard visualizations. That's everything. And nowadays, I also recommend that you do not learn the complete D3 documentation, because most of the stuff, or let's say, almost most of the stuff maybe is not needed anymore when you combine it with Svelte, and Svelte is easier to learn and to understand in many ways. And that is because Svelte has a declarative coding style, whereas D3 has a more imperative coding style. So that means in D3, you really say, do this, do this, do this, and in the end, you have your visualization. But in the code, you really cannot see the visualization because it's imperative, do this, and do this, but we do not see the result. And on the other hand, Svelte has a declarative coding style. You'll see that in the code editor in a second. So that means we really write HTML code that describes our visualization. We can really write, here is the axis of my scatter plot. Here is a data point. So we can really write that. And that, of course, if you work in a larger team, makes it really easy for your team members to understand your code. So when you hand over code parts or you want to reuse code parts, then it's quite easy to exchange the code between your team members, because it's really easy to understand. All right. So I would say we'll have now a look behind the scenes. And for that, I show you now a little model that we want to implement. So here on the right-hand side, you see a simple scatter plot with a connecting line. And on the very bottom, you see this ABCD selector. So it seems that, or yeah, it is that you can select different data sets that are then visualized in the scatter plot. So very easy concept. And on the left-hand side, you can see how we would build up that with Svelte. So there is an application module. There is a chart module, which is within this application module. And then we have within the chart, we have the axis, we have data points, and we have the line. And the concept now is that we build these different components. So that's the wording from Svelte. So an axis would be a component, a data point is a component. And these components should only know what they need to know. So for example, the application is responsible to get the data for the scatter plot, and maybe to also get some config information, maybe a chart title, maybe the ranges of these axes here. And then together with the config and the data and with the selector here, we produce a subset of the data which needs to be shown. So if the user is just selecting here A, then we only want the data of the data set A to be shown. And if the user clicks on B, then we want the data set B. So this is handled by this application component, which is the parent component of everything. And then we have the chart. The chart itself knows its width and its height because it's defined by the browser window. So remember, we're building an application here for the web, and in the web you have a million different devices. You have small smartphones and large desktops. And so the chart has a width and a height, which is really dependent on the user's device. And from this width and height, which the chart just knows, and I show you that how it works. Of course, we can compute scales, and scales means, okay, so I have a width of, for example, 300 pixels, and my data goes from 0 to 10, and then the scale is responsible to transform my coordinates of the data, like the 0 to 10, to the pixel world of my device screen, the 0 to 300 pixels. So these scales can be calculated within the chart component. And then, of course, from the config, I could ask, okay, how large should my axis be? So here, for example, they go from 0 to 20, and from 0 to 16. And together with the scales, I can tell them the axis, okay, hey, axis, you need to be from pixel 0 to pixel 300, and this is your labels and so on. And the same for the data itself. So we send the data inside the chart. Together with the scales, we are able to transform the data into the pixel world so that we know, okay, data point 1 is maybe at this pixel position. And these pixel positions, we can send them then into the data points and into the lines so that the data points can draw themselves. So everything is encapsulated, and the idea really is here to make it highly reusable. So we want to reuse, for example, these axes in different projects. We want to reuse the data points in different projects and so on. And this is what we are trying now to build a little bit. So I prepared here a typical Svelte project. And as a root component, we have here this app.svelte. And I know that some of you might never have seen a coding window, but I tried to explain it so that you can also follow what's happening here. I think it's possible because Svelte has really this declarative coding style. And each Svelte component divides in 3 parts. So here, this is our app Svelte component, which is the outer application component that I showed you in the model. We import some data here. And we have this selector component here that we import. Then we have here in this part, this is the HTML part. So this is really what we see on the screen. I already prepared it now that there is a selector. And we have this style part here, which adds just a styling to what we see here in the HTML. And if we go to the browser right now, and I try to bring that side by side a little bit here, we can see, okay, there is already an application now. We can see here is the selector, which has here the possibilities to select A, B, C, and D. I won't go now in detail how the selector is built up, but I share the GitHub link in the end, so then you can also have a look on your own how this is looking like. And what we now can do here is I just go to the developer tools, and yeah, let's get the console here. So, and let's just check what's happening when I'm clicking here on A, B, C, and D. And you can see that we have here a variable with the selected option, which starts with A. And the selector has this selected option also coupled. And in Svelte, you can use the $sign and then just write some statements. For example, console log selected option. That means every time selected option is changing, then we write the selected option to the console. So that's the effect of this $sign here, which is valid JavaScript, by the way, which is a label in the JavaScript world. But anyway, that just means for Svelte, okay, every time something changes here in this assignment, in this statement, then just rerun that. And that means now when I store that, you can see in the beginning, it just writes A. And when I then click here B, it writes B. And when I click C, C, and so on. So this is now just the reactivity concept of Svelte, just with this $sign. It means, okay, run this console log whenever I click something here. And what happens then in the end is that here I take my data, and dependent on the selected option, I use the data set A, B, C, or D. And if we just have a look at selected data, then we can see that at the beginning, we have this data set here. When I change to B, then I get a new data set. When I change to C, I get another one. These data sets are always built up in the same way. It's just an array of 11 data points that always have an X property and a Y property. And now the task is to just produce a scatter plot, which is showing these points. And as I've showed you in the, let's just enlarge a little bit for now. As I showed you in the model that we've built, we now can just produce here a chart component. And I've already coded the basic chart component that we also always use in our project. And if I want to use this chart component here, then I first need to import it. So I just grab the chart from components, chart.svelte, that's just the location where that file is. And then I can use the chart. And then you can always see that now our selector moved to the bottom because here still empty is now our chart included. And if I go to the chart, I can show you how that looks like. And you can see that there are these exports, and these are variables that we need to fill in from outside. So it's just the data that needs to be shown, and it's the X range and the Y range, which means how large are these axes basically. There's also width and height, which is basically the width and the height of our chart. So how do we know the width and the height of our chart? And it's one of the features that I really love with Svelte. So we can just produce this div here, which is a container for our chart. And then we have here with this bind client width and bind client height, we couple the actual width and the height of our chart to these two variables. And then within the container, we define an SVG, which is the basis for the graphics now, with just this width and the height. So let's see how that works now. So we can see, okay, we need data, we need X range and Y range. So I go back to the app.svelte where you have our chart here. And I say, okay, data. So which data do we want to fill in? It's just the selected data. And then we have an X range. And the X range, we just set it manually now as an array, which is like, I don't know, 1 to 18 maybe. That just depends on the data. We could also program that dynamically, but in the interest of time, just do that statically now. So we say, okay, data is always the selected data. So the chart only knows the selected data sets, and it's not interesting for the chart to know that there's also other data sets. And we have the X range and the Y range. Now I get this data here into chart, and now I'm able to define the scales. And here we'll now use for the first time D3. There is a function which is called scale linear. And I can just write it like that. And then I can say, okay, we have an X scale. And this X scale is defined with the scale linear function. And that takes two methods. There is one, a domain. That's basically the X range that we have available. And there is a method which is called range. And that is just the pixel world then. So that means here for the X scale, we go basically from 0 to width. And that means that now this X scale can transform my data, so the X range, which is already an array, so I do not need those, the X range to the pixel world. So you see that, how it works when you see it in action. And I also use that now with a $sign because I want every time the width is changing or every time the X range is changing, I want to recalculate this scale. And then I want to also do the same for the Y scale. Here I put in the Y range, and here I go from height to 0. And now I have my two scales. And basically, now I can build up my rendered data, because right now, if I again do just the console log of data and just go here, let's make it a little bit bigger. Then you can see, okay, here's now the data in, and the data has just these X and Y values, which is of course not pixels, but which is just in the coordinate system that someone used. But we want to use our full space here, and we want to transform now these X, Y positions into pixels. And this is exactly where we can now use these X and Y scales. So I always call it rendered data. So we define the rendered data for the actual screen. So we use the data. JavaScript, we could iterate over all this data with the map function. And we can just say, okay, build us a new X for each data point, where X is basically X scale dx. So it takes the current X position, puts it in our defined X scale function, and returns X pixels. And we do the same for Y. And then we get rendered data. And now I can again check how the rendered data looks like. So here we get a little error, Y scale, so I have a typo here. And now we have here the data, and you can see now the numbers are really high because this is pixels now. And now the only thing which remains is now we need to show the data points. And this again, in the Svelte world, we just do not now write here circle or whatever, but we build up a new component, which is basically data point. Let's call it like that. And a data point basically has an X value and it has a Y value. And now the question is, okay, we have 11 data points. How do we do that? And therefore, Svelte comes with something which is called an each block. So we could take the rendered data as D, for example. So it just iterates over this rendered data array. And then we can say, okay, let's grab X and let's grab Y. And then we create a new component, which is just called datapoint.svelte. And I would say, in the interest of time, let me just copy paste that from the final example, and I explain how it works. So here again, you can see here is these exports, which means, okay, X and Y comes from outside. And I could just use now X and Y to draw a circle. And that would basically just work. I always do it like that I do not position the circle directly, but I put the circle into a group, because then I could also label the circle and I could translate the group to the current position. So just that you see it, I just leave this stuff out because it's not necessary right now. And I could just say, okay, let's just transform the whole group to our X and Y position and then draw a circle with a certain radius that I defined here. Then here data point, you see the yellow line because we do not have imported it. So we also need to say, okay, import our data point from components and data point.svelte. And now we can have a look where maybe data point is not defined. No. Where's this error coming from? 10. Yeah, you know, that's always the thing. Yes, sorry. We are, of course, already in components. Yeah, now, okay. Now we get the data points here. And you can also see when I change the data set, it's just updating automatically because it just gets the new data and it just draws the new data because we have these $ signs everywhere. And now what's not so nice is that they are just flipping from one position to the other position. So let's just, as a last action here, build in the stuff that I commented out here. Because Svelte also comes with something which is called these tweened stores. And that means that we can define variables that I now call this tx, which is tweened x and tweened y. And you can use then this function to define some things like now you want to animate between different positions. So we want to move the dots around. And then we can say here that tx always is set with the current x when x is changing. See the dollar sign again, and the same for y. And then with this dollar sign, and that is something I would refer you to the Svelte documentation if you're interested in that further, or you can also contact me directly, of course. With that, these tx variables now, as they are defined with this tweened, they can now animate between different x and y data sets that are coming in. And this is looking then like that. So when we change here between these different data sets, everything is moving around and looking smoothly. And in former times, you had a lot of D3 code to do that. And here it's just these tweened variables that you use. So yeah, to sum that up a little bit, so we built this app, and you can see that Svelte is really there for doing all the DOM manipulation, for building up the whole application. And we only use certain D3 functions like this scale linear here, because D3 is perfect for these graphics, math and paths and transformation stuff. And this is how you best combine these two. So if you know D3 a little bit, there are this whole range of select functions, for example. So I wouldn't recommend to use them at all, because that's everything done easier by Svelte itself. So let's just go back to that one here. And maybe if you give me 2 more minutes, then I can show you just some 2-3 examples in the wild, how that looks like. Christina is nodding, so okay. So let's just have a look how that could look like when you build up more complex applications, for example. So the end of last year, we had the challenge to visualize different or the high number of corona deaths in Germany, which are more than 100,000 now. And we thought, well, how to visualize this high number? How can we do that? Because everyone knows these numbers every day, and there is some psychic numbing, and people are not moved anymore by these numbers. So we thought it might be quite a cool idea to build up a scrolly telling, which moves us through the time from the beginning of the pandemic to the end. And every time someone died in a specific region, so that's the data we had, then we burn a little point into the screens. And this is also an application where we made heavy use of all the different Svelte features with the transitions, with the a lot of different components. Here we also combined it with Webgl to draw these 100,000 points here on the map. And you can also build up, of course, static graphs. So when Angela Merkel resigned last year, we had like these charts where we compared her chancellorship with the length of different other leaders in Europe and the world. And Svelte here is responsible to position, for example, these labels, because when you're on the mobile phone, you don't have, of course, this large space. You need to be a little bit more narrow. So this is all handled by Svelte here. And another piece that we built for the Nobel Prizes is that one here, where we showed the current or last year's Nobel laureates in the context of all Nobel laureates. And here you can see a lot of different transitions that are all Svelte tweened variables. And you can use different chart types here, of course. And this is now built not with SVG, but with Canvas. So you could use whatever channel and drawing technique in the browser you need. It all works with Svelte and D3. And just recently, we built these little Olympia widgets, which are showing here. This is Bob runs at the Olympic Games. And so you can basically build everything that you can sketch, more or less. This is the same for speed skating, where it was quite interesting to use the same speed skater 6 times from different Olympics or so and to run this together. This is also built with Svelte and with the use of some D3 functions, of course. Yeah, and with that, I hope that I could show you a little bit how Svelte can work with D3 and that it's so powerful to build quick and accurate and nice looking creative data visualizations. So of course, just scratching the surface here. But yeah, if you have any questions, I'm really happy to answer them now, or yeah, you can also contact me afterwards, of course. And here are just some links that we can maybe also share through the chat. Thank you.
Thank you, Matthias, for a great presentation. I'm also new to Svelte, so this is actually really interesting. I saw from Benji's poll that a lot of people also knew, so I hope this was a good introduction to that topic. We have a bunch of questions in the chat that maybe we can go through. So Lian is asking what you would recommend as resources for learning Svelte and D3.
Yeah, so for Svelte, it's really the Svelte website, svelte.dev. I just dropped that into the chat. They have a really cool documentation, and it's not much actually. So the Svelte documentation just shows everything, and everything is not much, but it's really cool to learn everything here. And they have a little tutorial where you can click through and code a little bit directly in the browser. For D3, yeah, that's actually a little bit difficult. So I would learn D3 by examples. So maybe just go to the Observable website and have a look for D3 examples and how people use it there. Because when you learn D3 with some of the typical D3 tutorials, you learn a lot of stuff that you actually do not need if you combine it with Svelte. And yeah, that would be my recommendation.
Okay, thank you. Another question, do you have any experience of using Hugo to deploy these kinds of visualizations on the web?
What to deploy?
With using, yeah.
So you mean the static site generator, Hugo?
I think so.
Yeah, actually, I built my personal website, higsch.com, that is built with Hugo and some Svelte that perfectly works. So the thing is that Svelte only produces JavaScript in the end, which is valid in every context. And so you can basically combine it with any other tool that is out there.
I see there's a discussion here on how Svelte works with complex path transitions and if there's any alternative to D3 interpolate path.
Yeah, there are alternatives. It always depends a little bit on the applications. So just thinking if so D3 interpolate path is a popular package that is always good when you have a path that has a beginning and an end, and then it can convert between different path appearances really nicely. At the moment, when you have closed paths like circles and polygons, and you want to morph them to other circles and polygons, there is Flubber, which is a really cool library as well. So these two are basically what I am also using all the time.
And now a question more about the whole system. Do you, if you have one, and if you do, how your templating system works, basically, how do you keep your apps looking the same and having a similar code styling, like regardless of who's working on the code base?
Yeah, Yeah, that's an important one. And this is something we are just building up here at Der Spiegel. The idea is, and in parts it's already working really nicely. So usually all our designs are defined in Figma. And so you have Figma styles and design tokens, basically, that define a button, for example. And then from Figma, we export the design tokens as a JSON. So we have basically a long file where all these different styles are defined. Let's say, okay, there's a button, it has a background color, it has a font size, font family, and so on. And then we have a little script, which is coming from the Amazon style dictionary, basically. And that is transforming this JSON into CSS variables. And then we can import these CSS variables into our projects. And then we just say, okay, we want to have, for example, a certain font. Then we do not look up, okay, how was the name of that font again? But we have like standard font types and variable names for that. We just use that. And then it's just taking the right CSS variable. That's one part. And the other part is that we have a toolbox of different Svelte components that we use all over the place. If we stay with that button example, then we have a Svelte button component. And then at the moment, we just copy paste the code from this library into our own projects then. And then we automatically have the button. It already have the right CSS styles, the right dimensions and stuff like that. And in the near future, we want to put that on NPM so that you don't just say, okay, NPM install button in your project, and then you get the button. But that's basically these two levels. So we have these component templates, and within the component templates, we have these CSS variables that are coming from our one source of truth Figma file. That's how you can stay consistent all over the place.
Yeah, it can get tricky, right? When you have multiple applications to keep them looking consistent.
Yeah, exactly. And we also want to have all the style information in every project, because think of when the people here in the tech department say, okay, we rebuild now our website, and now all the styles are at a different place or so. So we wanted to have our projects autark so that they all have the data. And yeah, right now it works like that when we start a new project, we have a little NPM script or node script that just copies from our template projects everything you need, copies in the CSS variables, and then you can start with that, which works quite nice at the moment.
Maybe like a related question to this, does Svelte play well with the CMS in your experience, or do you have to do something to get around technical issues when publishing?
Yeah, no, it works really nicely. The reason again is that Svelte in the end is just standard JavaScript, and that can be included everywhere. So we have basically two methods to include our graphics to the website. One is just including an iframe. So then like you have a little browser window in the browser window and you can do whatever you like. That's maybe the easier way because then you are split off from the whole CMS around. The other way is to include it directly to the website, which is a little bit nicer. And in terms of the scrollytelling, that's the only way it also works. And then also it's quite nice. So it was a little bit of discussion, of course, with our tech team. And but in the end, now it worked quite nicely, and it's usually no problem.
Okay, thank you. We also have a question on using live data. If it would be possible to use this kind of workflow to make a visualization where the data points would be coming from, for example, a CSV hosted on GitHub.
Yeah. Yes. Now in my example here, I mean, what I did, where's my mouse here? What I did here is just that I import the data here very statically, and data is just here, this JavaScript file. But of course, your data source could also be some CSV. And then here also D3 will help you because D3 comes with a function which is called CSV. that you could just use, and the CSV function is just here using the path to wherever your CSV is located. And it's just loading it and giving back an array of the data that you can use then. So this will then like run when the application is loading. If you want to use data that is updating like every second or so, then of course you could also use technologies like WebSockets that is fetching then the data into the application. So that's a nice thing here. As well, it's just JavaScript. You could use whatever other JavaScript library like D3. And here, in the case of the CSV example, the CSV function of D3 would be your friend.
That makes sense. I saw a question that I think disappeared now on working with Webgl, if you use any wrappers for that, or how that works in your experience.
Yeah. So, I mean, for Webgl, you have different possibilities. Maybe the most popular library, which is Three.js, also works cool together with Svelte. So you can just use it within the Svelte world. And usually Webgl draws everything on a canvas. So you need to initialize that canvas into your HTML, and then you couple it to Three.js, for example. For many things, I also use the Webgl library. So that's here, that's their link, Webgl.party, which is a very low-level Webgl library. And there you have a lot more possibility, not possibilities, but a little bit more liberty to design your stuff. But of course, it's a lot more code than in Three.js. So yeah, Three or Webgl.party, and there is now also something which is called Svelte Cubed, which is basically a merge of Svelte and Three.js, and which tries to use the component model of Svelte so that you have these different components for data points as well, but also using Three.js for the rendering then.
That's pretty cool. Thanks for sharing. We also have a question on the enter, update, exit paradigm. How it's managed in Svelte?
Mm-hmm. Yeah, it's more or less managed by the way. So yeah, that's I think among the D3 users, that's quite popular, the enter, update, exit pattern. So that's how you bring data onto the page, how you change them when the data changes, and how you remove them eventually. So here we have something similar. If I go again to the chart component, basically this here is handling the D3 enter, update, exit pattern. Mm-hmm. So this here just means, okay, render data. When this array is filled, then it starts to render these data points. This would be your enter pattern. Every time render data is changing, so I get a new data set, then the new data is passed into these data points. Those are not rebuilt, but those are just updated by Svelte. So this is done under the hood. So you just get new X, Y values in. That would be the update. And if the render data is an empty array or some invalid variable again, then all these data points would be vanished from the screen. So this is maybe a little bit the translation. Then everything which has to do with the appearance of a single data point, that is then handled within the data point component here. So like, I don't know, the radius or the color, or if this is like images maybe, and so on. So everything encapsulated. Okay, thank you. I have, if there's no more questions in the chat, I have one more question. How would you say Svelte compares with React, for example, when working on these kinds of projects, or if you have any experience with that, and if you do, what the difference was in working with these two different tools? Yeah, it's a lot easier to use Svelte from the developer experience. So React is a bit more cumbersome, definitely, because you do not write HTML code directly. You write the JSX code for people who know React. So you write the HTML within the JavaScript world, basically. That makes it a little bit complicated. And it's also more complicated to include other libraries. So D3 is quite simple there. You could also just use it. but you need to be sometimes familiar with store concepts of React and so on. But maybe the biggest difference is actually on the user side. React works with the shadow DOM. So that means that when a user does some interaction, then a new DOM is calculated, and then React is looking, okay, what's the difference now? Which parts of my website do I need to update? And this is calculation time that is happening in the browser, so on the user side actually, and you need to ship this whole React library to the browsers. Whereas Svelte works different. So all these dependencies between interactions and variables and parts of the page that changes are pre-calculated basically when you as a developer build the project. And it's working then a little bit like maybe like Microsoft Excel, where you have different cells and you have then the sum of different cells. And when you change like one cell, a 5 to a 4, so also the sum changes immediately, and Excel does not need to check every cell which needs to be changed, but it just knows, okay, the sum cell is dependent on my input cells. And this is how Svelte works. So it's a lot more efficient, and you have a lot less file size that you need to ship to your browser. So yeah, when before I joined SPIEGEL, I worked 1 year as a freelancer, and there I had some projects which were still React because there was some legacy code from the client, for example. And it was always so cumbersome to go back to React again. And you have the feeling that you write so much more code than it would be when you would use D3.
Super interesting. Thank you for that. All right, I think we went through all the open questions. If there's not anything else, no, I think that's it. So Matthias, thank you again for a great presentation for the live coding session. It was a great introduction to using Svelte with D3. It was great to see some live examples in the wild. Thank you for that. And thank you everyone for attending. Our next meetup will be on the 29th of April. We'll have Erica Gunn, who will talk to us about data viz and UX, marrying data viz and UX. So stay tuned for more details on our meetup page. And thank you everyone again for asking questions. And thank you, Matthias, for the great presentation and for going through all of our questions. And see you next time. Thank you.
Yeah,
bye.
Thank you very much. Bye.